So our next chapter is going to start with 7.3, and we'll do a few chapter 7 sections and a few chapter 8 sections. So chapter 7, 7.3, we're going to talk about polygon formulas. So polygons are named by the number of sides that they have. So a three-sided polygon, you guys already know this, but you might not know that it got its name because it has three sides, is a triangle. A four-sided polygon is a quadrilateral. A five-sided polygon is a pentagon. 6 sides is a hexagon. 7 sides, now this is where we might not, I feel like probably 3, 4, 5, and 6 sides. You're pretty familiar with these. 7, 8, 9, 10, and so on. We might not know these, the names of these polygons as well. So a 7-sided polygon is a hept, H-E-P-T, agon. So be careful with these. Hexagon and heptagon are pretty close. It's easy to mix them up. So one way that you could keep those straight is remembering that if it has 6 sides, you would spell that S-I-X, which has an X in it, and hexagon also has an X in it. So just a little trick to help you out. All right, an 8-sided polygon is an octagon. That's one you probably knew. 9-sided is a non-agon. 10 sides, decagon. You could remember that a decade has 10 years in it, so decagon has 10 sides. 12 sides is a dodecagon. 15 sides is a pentadecagon. And then if it has n number of sides, we call it an n-gon. So for example, let's say that it had 20 sides, we'd call it a 20-gon. Just because they don't have names for every single polygon out there, just the ones with smaller sides that are more common. So do you guys think that you have to know all of these names and have them memorized? Absolutely. So maybe make a note to start working on memorizing these. Alright, so we're going to put some formulas in our notes. The first is for the interior angle sum. So what that means is, let's say you have a polygon, it's a triangle. If you were to add up the 3 angles, what would the sum be? And the way that we find that is by using this formula. It's going to be an S and then sub for subscript, so S sub I, and that stands for sum of interior angles is equal to 180 times n minus 2. So down here, SI stands for sum of interior angles. And then n stands for the number of sides. Alright, we also want to know the exterior angle sum. So what that is I'm just going to draw this down here and talk about exterior angles for a second. Let's say you have a triangle. I'm just sticking with triangle because it's an easy polygon to work with right now. The exterior angles are if you were to extend your sides going all the way around, so extend that, and extend that. The exterior angles are these angles that are on the outside of the figure. So what is the sum of those 3 angles? And if you had a quadrilateral or a pentagon, you'd have more angles to add up. Well, the interesting thing about that is that the sum of exterior angles, so SE, it doesn't even matter what polygon it is, it's always going to equal 360. So all exterior angles will add up to 360. All right, the last one, oh, it just went away. All right, wrote it back in. So the last one is the total number of diagonals in a polygon. So let me show you what diagonals are. I'm going to pick a bigger shape, let's say a pentagon. So a 5-sided polygon, like that. Diagonals are going from one vertex, so you pick your vertex, and you want to go to the other vertices of the polygon. So right there, that gives us 2 diagonals, and you want to go to another vertex and make sure you get all of the diagonals. So here's the next vertex. You don't necessarily have to identify the vertex by putting a point there. I'm just doing that so you can see where I'm working. I'm going to go to any vertex that I can draw lines to. Now I can't go to this vertex here because that actually is the side of the polygon, so you have to draw lines inside of your polygon. Alright, so then moving on to the next vertex, I'm going to draw a diagonal there, and then if you notice, I already have that diagonal drawn, so I don't need to draw anymore. And if you were to check your other vertices, all the diagonals are drawn. So this one has a total of 5 diagonals. The formula to find that, D equals n times n minus 3 divided by 2. And again, n is your number of sides on that. And the last thing for our intro video is we need to talk about this midline theorem. So midline theorem says if given a triangle that has a line drawn from the midpoints of 2 consecutive sides, the following things are true. So before we talk about what's true over here, let's make sure that this makes sense. So we have 2 midpoints. E is a midpoint and H is a midpoint. So E is the midpoint of DF. So you can see DF, we have it split it into 2 congruent segments, and then H is the midpoint of DG. So if you have a triangle where there's a line drawn from this midpoint to this midpoint, these 2 things are true. EH, that's our midline, so EH is the midline, is equal to half the distance of FG, which is the base of our triangle. So EH will always be half of FG, or 1/2 times whatever this length is. So that's always true. And then the other thing that's always true is that EH will be parallel to FG. So your midline will be parallel to the base. So if we look at our figure, let's say that our base is x, because we don't know how long it is. So FG is equal to x. That means that EH is equal to half of that. So we would say 1/2 x. That is an x. If FG was 10, then EH would be 5. All right. Okay, and then they are parallel, so we can go ahead and mark our little parallel arrows, just showing that those will always be parallel. And that's your midline theorem, giving you those 2 helpful pieces of information.